Being able to look around the world is definitely a nice improvement over what we had before, but I want to be able to move my camera around the world. That is, when I push a forward button, the camera moves forward. When I push backwards, moves backwards, that kind of thing. I'm a keyboard gamer, so I'll use the keys W, A, S, D as arrow keys. W will be forward, A will be strafe left, S will be backwards, D will be strafe right, so it's kind of arrow key-ish. And then I also want the key R and the key F to move the camera up and down. So when I push R, the camera will go straight up in the world coordinate directions. We'll just simply move the camera along the up vector. And then when I push F, we'll do the same thing, but go in the negative direction. Let me show you how to make a camera move, though, in the world position. Remember this diagram we've seen 10,000 times. Let's just say our camera is sitting right here, and the view direction is that way. Let's just say it's perfectly sitting in the XZ plane here. It's not pointing up or down. It's pointed towards like this corner of the screen. And my dog is making some weird noises in the background, so I hope that doesn't disturb you. You okay there, buddy? Well, it's easy. If I want the camera to move forward, I'll recall. Oh, where's the origin at? Let me click here. Show the camera. All right, so this is the actual origin of our world. Let me take that other camera off. Oh, I just moved it. But that's the origin of our world. We have a position vector that I will do in green. We have a position vector, and we have the view vector. In order to make the camera move forward, all I have to do is add a scaled portion of the view vector to my position vector. For example, the position vector plus part of the view vector would give me a new position vector like so. So it's real simple. Just add a scale, slam that, or multiply a scalar to the view vector, add that to the position vector, and that'll move forward. Guess how we move backwards? Well, we just negate that operation. Strafing right or left, the idea is similar. Our camera's here. It's viewing that direction, but I want to move the camera to the right. Well, I just showed you in the last video how to make a vector that points to the right. In fact, we have it in our code. We crossed the view vector with the up vector, and that gave us this vector pointing out to the right. So if I want to go to the right, or if I want to strafe right, which I will assign to the D key, then I just need to reuse that vector. And same thing, add the position vector to the right pointing vector, and that'll help me strafe right. If I want to strafe left, well, it's just the negative of that operation. And then to make the camera go up and down, R will be up and F will be down. I just have to move the camera position along the up vector. So let's go back to our code and make all this magic happen. First thing we need to do, though, is get the key events from Qt. So I think it's void key event. Key press event takes a Q key event pointer. And let's go implement this in the GL window CPP file. And we'll put it with the mouse move event. We'll put it down here. Grab this. Oops. Control C this. Control V it right there. Bring this in. And say E there. We need to pound include Q key event. Control L, Control V, V, Q, not mouse, key event. Control minus, minus to get back to where we were at. Switch E key case Qt key code, is it? Key W. Oh, key W, sorry. We want to say camera dot move up, like so, break, and let me fill this in. Control C, actually, you know what? I'm going to grab this, paste it there, take that out, and take this out, and then I know we have 1, 2, 3, 4, 5 more keys, so Control V, 1, 2, 3, 4, 5 more keys. WS will be camera move down. A will be camera move left, and D camera move right. Actually, not move left, move right. Let's put strafe in here. Strafe left, strafe right, key, R, camera, and this is going to be forward, it's not going to be up. Move forward, move backwards, backward, and this will be move up. I want the camera to move up along the up vector there, and then this will be move down, that will be key F. Now I could kind of get rid of all these switches and cases if I wanted to start passing vectors between my GUI and my camera, and the GUI could determine what to do. But anyway, let's we need to put all these functions in our actual camera. So camera.h public. I wish Visual Studio 2012 supported macros, because that would be really useful right now. If you go look at my Visual Studio macros video, you'll see why. At least I can do an alt drag here, void, and we already have the semicolons, so we should be good. Let's go and implement these in the camera CPP file, and highlight, shift tab, alt drag, camera, : and move forward. I'm just going to throw a dirty constant out here. Const float movement speed. So we'll make that part of our class later. We'll just say for every keystroke we'll move 0.1 units in the world. Remember that the grid makes up the units here, so this would be 1 unit here, and 0.1 unit would be a tenth of that. So it's probably a good speed to start out with. Movement speed. So to move forward, it's simply our position plus equals view direction. We'll scale view direction by movement speed. This is the reason why we made our view direction a normalized vector, so we could scale it later for the camera movement. To rotate around a vector, it doesn't matter if the vector is normalized or not. And we've been doing a lot of rotations in the mouse update, but we didn't really need a normalized view direction vector to make that happen. But to keep our camera movement consistent, it's good to keep that normalized. And so we have a direction and we have a speed. And vectors are a magnitude, or a magnitude and a direction. Magnitude, direction, magnitude, direction. Go look up Vector Despicable Me 2, I think. There's a little 10-second clip in there where he's like, I'm Vector with magnitude and direction, my boy. When I was teaching my boy about vectors, he blurted that out. And I thought, oh, that's kind of fun. I'll check that out. Let me fill these in like so. Oopsie. And if this is really boring to you, filling all this stuff in, you can either stop the video here, or you can easily fast forward to see what I did. But this isn't going to be much rocket science. Move forward, movement speed times view direction. Move backwards, hey, it's the same thing, but I'm going to go in the negative direction instead. Strafe left, oh! I got a scope issue here because I have our to rotate around vector is here in this function. I could make this a class member variable, but then I'm never guaranteed that the mouse is moving while the keyboard is moving. I don't know if that really matters, actually. It could. I don't know. That's just, it's cheap to do the cross product, so I'll just do it right here. I'll do it again. Copy, paste. Look at me, I'm a champion. To rotate around, this is a strafe direction. Copy, paste. I'm feeling kind of dirty about the copy and paste thing. Same idea as we did right here, except we're going to use our strafe direction. So position plus equals movement speed times strafe direction. If we're strafing left, it's going to be in the negative of our vector. And if we're strafing right, then we want to be in the positive direction. Move up. Well, move up's really easy. It's the same thing we've done before. Position plus equals movement speed, but instead of going down the strafe direction or the view direction, we want to go with the up vector, like that. So to move up, we'll go up, and to move down, we'll go negative of that. So I think that's good. Let's go back to the GL window. And in here, after we do all this magic, we need to repaint our scene again. Okay, here's hoping this works. Control F5. Build this, run this. Of course it fails because I already have it open in the background. Close that, close that. Control F5. And camera's still looking around good. I'm going to start using the keyboard here. Let's do forward. Backwards. Isn't that feeling good? Here, let's turn a little bit. Forwards. Backwards. Oh, watch this. Forwards. Turn. Backwards. Left. Right. Left. Right. Good job. I'm hitting R. That's moving us up. Get a nice bird's eye view. F. We'll go down. And we're looking up at it. So, yeah, cool. We have our camera. That actually wasn't that hard. It's just a little bit of vector magic. It's actually not magic. I hope you go study up the vectors in my game engine programming playlist and on the Khan Academy videos, and that'll get you up to speed. But there we go. We have our camera. And again, I was editing this video and realized I was feeling kind of bad about my magical number I left out here, this movement speed. Let's actually make it a class level constant camera, and we'll just say const float movement speed. We shall say static out here though, static, and so now it's a static const float, but it won't build because it's a float and not an int. The compiler will allow me to do this with ints, but not with floats, and it has to do with how floats are stored and that sort of thing. So I actually have to define runtime memory for it, which is essentially going back to the camera.cpp and pasting it right there how I had it before. But at least now the scope is a little bit more restrictive. I have to scope it into the camera. It's a private member of camera, so I can feel better about that. And I'm actually going to move it to the top here because I like to define my constants at the top of the file. And then another thing that was bugging me was this copy paste of code. I really don't care about the runtime overhead to calculate this. I probably should, but it's a cheap operation. But I actually feel bad that I had to duplicate this code. So it hit me that the strafe direction is whenever we do the mouse update, an invariant of my camera class is that the strafe direction always points in the direction that we should strafe to the right. And if I update that here, whenever I move my mouse, then that invariant will always be satisfied. So I'm actually going to go as far as using that invariant. If you don't know what an invariant is something that is always true. And as long as it is always true that my strafe direction is pointing to the right, the direction that I should strafe to the right, then all the other functions can assume that strafe direction is okay and can use strafe direction. Control C, Control Shift L to delete the line. For example, here we're going to use strafe direction and assume that strafe direction is pointing the right direction. It's a lot to do with class invariants with linked lists. That's another good example, linked lists. The invariant is every node points to the node in front of it, and if it's doubly linked, then it points to the node behind it. And so then in every function, you can assume that state. And as long as the function returns the class data back to that state at the end of the function, then the invariant is always true, and it makes programming a lot easier. Anyway, I digress. Strafe direction. Let's make it a member of camera. Strafe direction, GLM, vec3. Thank you, Visual Studio, for deleting my code. Control U, and semicolon. Visual Studio ate my homework. So now we took that out of here, took that out of there, and I can call this strafe direction right here. I want to rotate around the strafe direction. And we can also use strafe direction here and here. We no longer need to do this one. Control F5. Let's just ensure our camera is still working the way that, of course, the build filled. Movement speed, because I left this in here. Delete that. Control F5. Build and run. Let's make sure our camera behaves correctly. I am strafing right. I'm also rotating my camera. Strafe left. Very good. Back, forward, up, and down. Now, you'll notice, since we're relying on the QT windowing system, oh, look at that, the two cubes. We flew inside the cube. That's always fun. With the QT windowing system, when I push any direction, you'll notice a little bit of a hang, and then it will move. So hang, move, hang, move, hang, move, hang, move. That has to do with key presses. That's just the QT windowing system saying, oh, you pressed a key. Oh, you're holding down the key. I'll start firing that event really fast. So you pressed a key. Oh, you're holding down the key. Anyway, we can fix that by doing polling and getting our own loop going, our rendering loop going. I don't know if I'll go to the effort of that right now. I don't really care. But if you want to see how to do that, I have that in my game engine programming playlist. Go look up setting up the game loop and that sort of thing. And then you'll notice the movement with the keyboard is a little bit smoother. It doesn't lag or hesitate there. Anyway.